Hello. The following presentation is a look at how bioswales impact environmental, economic, and social sustainability in an urban setting. The presentation was prepared by Team Spruce for Hort 2300 at Olds College. Bioswales are also known as infiltration swales, biofilters, grassed swales, and inline bioretention. It is somewhat similar to a rain garden, but a sloped base to facilitate water movement is one of the unique components that distinguishes bioswales from rain gardens. Bioswales are constructed with vegetation growing in enhanced soil, and below that is a layer of gravel and baked clay pellets packed with geotextile. The lower material infrastructure has large spaces that allow it to drain through easily. Bioswales collect runoff water from gutters, utilizing the infrastructure that is already in place. As water flows along the length of the swale, the vegetation and the growing media slows and traps the water, cleansing it by allowing water to infiltrate into the ground. In urban settings, bioswales are constructed in residential and commercial areas, near parking spots, roadways, and parks. Plant species that are used for bioswales are picked based on its hardiness, if it's low maintenance, and whether it's a native plant or not. On a typical road, a 4-meter wide plot of bioswale can reduce 25% of surface runoffs, while also removing pollutants through filtration, sedimentation, absorption, or vegetative uptake. The longer the water sits in the area of a bioswale, the more pollutants that are filtered out. Stormwater detention reduces the peak water flow from the sites, therefore this mitigates possible downstream flooding hazards. Bioswales are designed to replace riparian habitat, which could provide homes to wildlife. Nitrogen is considered to be the most problematic runoff pollutant in the US. Nitrogen pollution has degraded up to 2/3 of the fish production, marine ecosystems, and recreation areas along the US coastline. Bioswales are commonly used to reduce pollutants such as nitrogen from entering waterways, but research has shown that bioswales can still contribute to nitrogen pollution. Figure 3 comes from a study in the journal Water. The authors found that the amount of nitrogen entering bioswales in stormwater runoff is typically much greater than the amount used by plants and microbial interactions in the soil. On top of this, soil microbes convert the excess organic matter that ends up in the swale into ammonium first and then into nitrate under the right conditions. These conditions are warm temperatures, fast draining soil media, and abundant ammonium. Nitrogen is also lost in smaller quantities to the atmosphere during these processes. Nitrate is water soluble and highly leachable when the next precipitation event occurs. Nitrogen is also simply lost to the waterways in the case of stormwater overflow. Figure 4, also from the study in the journal Water, gives a visual representation of the amount of nitrogen entering a bioswale, along with the amount exiting in various forms. Stormwater runoff typically provides more than enough nitrogen to fertilize plants in the bioswale, with no additional fertilization needed. Leaf samples taken at various sites showed that grasses and forbs uptake more nitrogen than shrubs and trees, although the authors realized that woody plant material also stores nitrogen in other tissue, so sampling plant tissue other than leaves may provide more clear results in future studies. The study concluded that maintaining a higher carbon to nitrogen ratio in the soil, above 25:1, can help to tie up some of the excess nitrogen entering swales. Some options for increasing the carbon to nitrogen ratios in a swale include using bark mulch, more mature leaf compost in the base media, or increasing the amount of coconut fiber instead of compost in the media. Plant materials used in bioswales in Calgary are usually lawn grasses or hardy, low-maintenance plants, as noted on the City of Calgary website. According to the Alberta government's Wetland Construction and Stormwater Facilities Guide, native species typically outcompete ornamental and non-native species, require fewer pesticides, and do a better job of filtering out pollutants. These plants must be able to withstand the varying amounts of water received, including the ability to remain submerged for up to 20 consecutive days, or up to a year without flooding. The guide recommends several zones around the area that will be periodically submerged. The first zone, the emergent zone, contains plants that can handle water levels from 10 centimeters to 60 centimeters, such as cattail, bulrush, horsetail, and hemlock water parsnip, as displayed in Figure 5. The second zone, the wet meadow zone, is located at a slightly higher elevation and consists of plants that can handle being submerged to a maximum depth of 10 centimeters, such as prairie cordgrass, slewgrass, and mannagrass, also shown in Figure 5. Beyond the first two zones, an upland buffer zone consisting of flood-tolerant native trees, shrubs, grasses, and flowers is recommended to reduce erosion and slow the flow of water. Clearly, the design choices and plant material chosen for the construction of a bioswale will greatly impact the performance of the swale and its ability to reduce environmental pollution. Bioswales offer the community a small piece of nature where typically none is found, improving the overall appearance of the area. Improvements in water management will just decrease the chances of property flooding in areas where bioswales are located, as well as manage the mosquito population due to the decreases in standing water. Having green spaces encourages the community to get outdoors and interact with each other, leading to a healthier community. In July 2016, students worked at a small garden designed to absorb rainwater in the Corona neighborhood in Queens, New York. In this picture, they are sampling soil in order to determine the correlation with plant health and drainage characteristics. When designing a bioswale for an urban setting, it is important to implement a design and build that protects the bioswale from erosion over time. Sediment within the bioswale may be lost during erosion, and reconstruction to regrade the bioswale and restore the proper flow may be necessary, which can become costly to cities. However, with proper design and construction of a bioswale and implementing native grasses and plant species within the bioswale, less upkeep and water usage can be the result. Native plant species require less water for plant growth, eliminate the need for fertilizer, and reduce the amount of mowing that is required by city employees. Bioswales must be inspected on a regular basis to maintain effective operation and reduce the chances of sediment buildup within the bioswale. Adequate amounts of vegetation must be growing at all times to operate properly and reduce the amount of maintenance needed to be performed. There are many examples of how cities have implemented bioswales to reduce costs associated with maintenance and water retention. When bioswales were designed and implemented to collect street water drainage in Lenexa, Kansas, the city was able to reduce their on-site retention costs by 25%. In Seattle, Washington, an entire city block was redesigned with right-of-way bioswales, resulting in reduced street and sidewalk widths and a 49% reduction in paving costs. A study done by the U.S. Environmental Protection Agency concluded that the majority of case studies that implemented how low-impact development bioswales had resulted in total capital cost savings ranging from 15 to 80%. The effectiveness of bioswales in reducing water pollution, along with its economic and social impact, will depend on the design of the swale, including plant materials, soil and drainage materials, and maintenance. A well-constructed bioswale using native plant species in the right locations and with the right design and engineering will have a positive impact on all life downstream. The integration of a bioswale in new city planning is an investment in the well-being of humans and wildlife, both in the short and long term. Thank you.